Hello, my name is Agustín de los Riscos and I'm going to present our published work on a conversational agent that fights against online hate speech. Before presenting in detail, here we have outlined each of the points we are going to discuss. First, we will see the context and objectives of the project in the introduction. Secondly, we will talk about the data we have used to train the system. Then we will present the two key components of the conversational system, and finally, we have the conclusion and the future lines. As we have presented in the table of contents, we will start talking about the context and objectives of the project. Currently, dealing with hate on the internet is a major challenge for social networking platforms and government agencies. This year, the Spanish government published an action plan against hate crimes on the internet. In the presentation, the minister commented that 45% of reported hate crimes come from the internet, showing that online hatred is becoming a real problem. It should be mentioned that there are already automatic systems that detect hate for a subsequent temporary blocking of the aggressor on the page. This blocking has two main risks. First, a possibility of coercing the user's freedom of expression, and second, a failure to prevent future crime by not correcting the user's behavior. Therefore, we propose an alternative solution to these account logs through an intelligent conversational system that can mitigate hate. Below, we have an example in which one user comments that he hates Muslims. As in the blue answer, the chatbot should respond in such a way that it makes the user see that his words are not correct. To develop our system, first it is necessary to implement an automatic hate detector, and secondly, to set up a dialogue generator, also automatic, that is able to respond to these situations, but that can also talk friendly to the user about any topic. In order to train the system to detect and intervene hate, it is necessary to collect several sets of data. For hate detection, we have found few published datasets. Among the most relevant ones, there are datasets from different languages, sources, and with different annotation structures, including data labeled by different types of hate. As we can see below, the dataset with the highest volume of comments and with the widest range of labels is Jigsaw. Jigsaw has almost 2 million comments in English, obtained from the Wikipedia form and Civil Comments webpage. Below we have the distribution of comments by category, where we can observe some imbalanced behavior between aggressive and non-aggressive class. We corrected this behavior by reducing the number of non-aggressive comments and equalizing them to the other class. Jigsaw, apart from having comments labeled as aggressive and non-aggressive, includes labels about the discriminated social group in 300,000 aggressive comments. As we can be seen in the graph, 38% of these comments are labeled as discriminatory by sex, and 28% by religion, with only 8% being Islamophobic. To be able to use this data, it is essential to make previous transformations to the text. For this purpose, we have followed the recommendation of common NLP processing. In particular, we perform everything from category filtering and normalization to final coding and truncation of comments. On the other hand, the mitigation of hate through a conversational system is an innovative task, and therefore there are few datasets oriented to the generation of counter-narratives. We have only found 3 datasets published recently. 2 of them were discarded for different reasons. First, the first dataset lacked information about hate content related to counter speech annotated in the dataset. The other discarded dataset had information about Reddit publications. As you can see below, this information has a very different annotation structure than a dialogue, with news in which more than 2 users can comment on the publication. Therefore, this dataset is hardly adaptable to our use case. In addition, in both data, its counter-narrative lacked an expert review to check the quality of the response generated. Finally, we were left with Conan, a dataset with Islamophobic phrases and their corresponding counter-speech. To be able to talk about other more general topics, the system has to be trained mainly with other types of dialogues. Persona Chat is a dataset with 10,000 dialogues that include personality profiles as additional information. In the example, the profile shown above corresponds to person number 2 in the dialogue. As we have said before, we employed Conan data to train the system's ability to generate counter-narratives. Conan consists of almost 7,000 pairs of counter-narratives that were reviewed by professional social media moderators. In order to train with this data, we had to adapt them to the Persona Chat format. As for the hate detector developed in the project, we can say that is a supervised binomial classifier. Our classifier, based on deep neural networks, was trained with Jigsaw and Conan, and finally was adjusted to detect better Islamophobic content. Now, in this slide, we present the architecture of the classifier. The detector, as you can see, is a 3-level neural network. The first level is an embedding layer that transforms each word of the input phrase into a vector. The final vectorial word representation is formed by a concatenation of a classical type of representation called glob and another representation called PPE that uses information about the subunits of words in order to better represent out-of-vocabulary words. The second level is formed by a recurrent bidirectional layer that builds the vectorial representation of the whole sentences. Once we have this representation, the phrase is classified in the decoded form by a multi-layer perceptron, regularization layers, and finally a softmax layer. We evaluate the classifier both objectively and subjectively. In the objective one, we obtain an F1 score of 73% in detecting any type of toxicity and train only with Jigsaw. In order to improve more the performance of the classifier, we retrain the model, including Conan data along with Jigsaw data, improving performance by 4%. After this training, we adjusted the classifier a couple more times only with Conan data. Thanks to this fine-tuning, we obtained a score of 84% in Islamophobia detection. We also carry out a subjective evaluation in order to analyze those cases in which the detector fails more. Looking at the confusion matrix, we can see that most of these failures are false alarms. After the results, we realized that these false alarms occur mainly due to the presence of insults or keywords related to Islam. Here we have an example of a false alarm of a comment that is clearly against Islamophobia, but as we have words related to the Muslim culture, the detector classifies the phrase as toxic. The dialogue generator is the other main component of the system responsible for automatically responding to the user. Our dialogue generator is based on the version of the GPT-2 model called Transfer Transfo that was the winner of the Com AI 2 contest. Our model, like theirs, is ready to talk about any topic because the language model used to form the answer is pre-trained and adjusted with persona chat. To respond to the user, the language model uses two types of contextual information at the input. One is the conversation history and two, the several personality profiles. One profile will be used when the conversation does not show signs of toxicity, and the other for the opposite case. In addition, a final version of the model was finally adjusted with persona chat, along with a Conan peer-to-peer extension to improve the generation of anti-Islamic narratives. In short, all the modification and trainings we have done of the original transfer make it ready to generate counter speech when the user shows hate in his comments. In the following diagram, we can observe the architecture of the model and how the generation of the response works. GPT-2 is a causal transformer, so it forms the response word by word. To predict the next one, the model takes into account the contextual information before and the sequence of words that the model has been generating in previous steps. In case the user shows certain aggressiveness in his comments, the system is configured to include, if desired, Conan information in both the profile and the history, with the aim of forcing the response to be a counter-narrative. Like the detector, an objective and subjective evaluation of the chatbot has been made. In the objective one, both standard dialogue metrics and metrics based on embeddings that observe the similarity between sentences have been calculated. For the evaluation, we have used Conan sentences that were not used in the training, and it can be seen that in all calculated metrics our model outperforms the original transfer, as we can see here in this graphic and here. After an initial implementation in which we had not yet trained the model with Conan, we conducted a survey to assess the chatbot. The 11 people who participated in the survey were asked to evaluate a couple of dialogues with different system configurations, and to rate from 1 to 5 all characteristics that we observe in the graph. The version that was generally best evaluated was the combined configuration, where both the system's personality profile and the conversation history are modified with Conan information each time toxicity was detected in the conversation. To make the system more accessible, has also developed a web application suitable to any device in which we can interact with the model through a chat, and we can observe the level of toxicity accumulated thanks to an indicator. The application consists of a client in React and a server in Node, with all the necessary middleware to handle the client's HTTP requests and send them to the system. And here we can see the final view of the system interface. At the end of the project, we have managed to meet the objectives and develop a system that is capable of detecting hate with an 84 F1 score and is able to generate counter-narratives when necessary. This system is an initial prototype, and we are still working to improve its performance at both the detection and intervention levels. As future lines, we have planned to use more complex architectures based on transformers for the detector part, to mount a more accurate classifier that can detect hate subtypes, to carry out a survey of the trained dialogue system with Conan, and to develop new functionalities of the web application. Any questions you may have, we will be happy to answer them by email. The system code is publicly available on GitHub for those who want to try it out and further research into hate speech detection and intervention. So that's all. Thanks for listening.